Hi, welcome to my podcast of Einstein's theory of special relativity. So, what's it all about? Einstein's theory of special relativity is based on two basic physics principles. These are called the two postulates. The first postulate is that the speed of light is the same for all observers. This is regardless of the speed of the light's source. And the second postulate is that the world should feel the same in all frames of reference moving with constant velocity. These are called inertial frames of references. Now, say there are two spaceships. One with a laser beam placed on the bottom of it, and the other with a mirror placed on the top of it. John is in his spaceship. He moves along and he shoots the laser beam at the mirror. So it goes down, then bounces back up. John also measures the time it takes for the light to return to the spaceship. From John's perspective, the light beam goes a straight up and down path. Now suppose there is a second observer on a nearby planet, Alice. From Alice's perspective, the light beam follows a V-shaped path. This is because the ships are moving across her and she must add the motion of the ships and the motion of the light beam between them. This V-shaped path is longer than the straight up and down path. The light beam must hit the mirror after the same amount of time passed. And since the speed of light is the same for all observers, how is Alice's view of the light beam covering a longer distance? Well, the only way for this to work is if time for John slows down relative to Alice. This is called time dilation. We mentioned that time can dilate, but distance and time don't increase by the exact same amount. In fact, time doesn't actually dilate enough to account for the speed to remain the same. When objects are moving close to or at the speed of light, not only does the time slow down, but the object itself contracts. So if John was in his spaceship zooming past Alice's planet at near the speed of light, Alice would see that John, along with his spaceship, has contracted. This is called length contraction. Special relativity is the fact that in our universe, length and time aren't absolute, but they are perceived differently by observers moving relative to each other, hence relativity.